All right, we are now officially recording. So if you want to go ahead and ask your question about the group project, go ahead.
Perfect. So I'm pretty sure it was Kaylin who brought this up a while ago, but she asked about maybe seeing an example of what you were looking for and what would be good point-wise. And I was wondering if you were able to find one.
Well, so the hard thing about it is I haven't found one and the problem is with the HIPAA rules, I can't show you somebody else's project. And it's just going to be a hassle to get that done. So let me just say this. If you follow the 7 or 8 steps for the hypothesis test, that's what I'd like to see. I'd like to see enough math so that I can reproduce your work. I don't need to see your raw data, but I should, there should be enough information there so that I can follow it. I need to see graphs, I need to see histograms. If they apply, I need to see pie graphs, bar graphs. If they apply, percentages of men and women, a lot of descriptive statistics, how old are your people, that kind of thing. Also, the calculations for your hypothesis test, there should be enough detail there so that I can take your numbers and I can see if you made a mistake. So, so I will still try to see if I can find something. I will tell you, format-wise, if you follow the 7 steps and you show me all your steps for your hypothesis test, that's what I want to see, as well as graphs like histograms of the ages and things like that. Percentages of men and women that you talk to, just the kind of descriptive statistics that kind of describes, who did you talk to? So we're not just guessing, were they old people, were they young people, that sort of a thing. So I got another question about, I'm trying to remember. I think one group had done the cluster sample before we all got quarantined. And the problem is the other 2 groups didn't. And so in order to keep these similar grading, I said a long time ago, if you didn't do that, then you needed to give me more telephone calls. So I instead of having 30 telephone calls, I think it was 100. And I think I'm just going to stick with that just so that people are graded similarly. So the social media, that one will be easy to do. So you can still do that one. The phone calls, you can still do that one. I'm trying to remember what else there was that you can do. If you did the potatoes, you can do that one. If you did the M&Ms, you can do that one. If you did the speed limit, you can still do that one. So essentially, the project's going to be a little bit smaller than in the past because most of you didn't collect the data in time when we could meet in person, and the school has asked us not to do in-person surveys. So it's got to be phone calls or social media. That's pretty much all you can do now. And then the potatoes or the speed limit, you can choose either one of those. And then the M&Ms, you'll have to do that one. So basically 4 parts: telephone calls, social media, M&Ms, and either the potatoes or the speed limit. So any other questions about the project?
That was really helpful. Thank you. Really quick follow-up question. Have you figured out a little bit on the format of how we're going to present and whether it's going to be in teams or what would be best?
Yeah, so it will be in teams. The idea here is you guys should be able to share your power. So I do want you to post your PowerPoint on Canvas. I can't remember if I've opened that up yet, but I will if I haven't. So post your PowerPoint on Canvas, and then you should have a share button, and then you guys can just share your desktop and then go through the slides and explain them. So.
Sounds good. Thank you.
Mm-hmm.
I have a question about grading.
Okay.
You had said earlier that like the quizzes might replace one of the test scores or
Right.
something like that. Does that count for the final, or is it just out of the 4 tests that we take?
It's just the 4 tests. It does not count the final.
Okay.
The department requires the final. So, in fact, they have some special questions they like to put on the final. So, I'm pretty sure, although I'm not totally sure, didn't I post a spreadsheet where you can track your final exam or your score in class?
I don't know.
Okay. Well, it doesn't really matter because Thursdays, well, I guess we won't have a quiz on Thursday because we're having a test. So I guess I will change Canvas so that your Canvas grades are accurate. Yeah.
Can you give
I'll probably do that on Thursday. Can I what?
Like a test review posted?
I think I already posted the review, and in fact, it's actually 2 reviews. If I look, let me share my screen. In fact, I'm sure I did because I posted that. Oh my gosh, what happened? I posted that over the weekend, so that's has been up for a few days already. If you go to Canvas, exam 4 and 5, this is 17, 20, and 22 key terms, and the other one is exam 5. We don't have an exam 5, but it was just easier. They were written separately, and so 6 and 25 key terms. So those are there. So any other questions?
How much of the final will be chi-square stuff? Do you know?
Well, we've got 17, 20, 22, 25, and chapter 6. So that's 5 chapters. I would say 20%. 1 out of 5. So it'll be pretty evenly. Say that again?
The final, is it going to be like our other tests where one is written and one is on Excel?
Right. So as far as the final exam goes, normally we would have our final exam on Tuesday, if my memory's right. And it would either be, let's see, I can't remember. I think I have my calendar. Do I still have my calendar open? I put on my calendar a long time ago. So we were scheduled for 9 a.m. to 11 a.m. on Tuesday the 28th. So what I will do is we will still plan on Tuesday the 28th. I will open it up. It will be open all day. If you take the written part during the hours of 9 to 11 a.m. and if you get uploaded, oh, by the way, did everybody take that proctorio quiz? The new quiz?
Yeah.
And it worked? Okay, good. Okay, so that should be good enough. So 2 things. Number 1, we have a test on Thursday, and if you take it between the hours of 10 and 11:15, take the written test. That's all I'm talking about. The written part needs to be between 10 and 11:15, then I will give you an extra 5% extra credit just for taking it during our regular class time. But if that doesn't work for you, or for whatever reason, you can take it anytime that day, and that's fine. You just won't get the 5% extra credit. I will also have the computer part of the test. There will be no time limit on that. I will trust that you have your formula sheets and you haven't written anything on there besides what's on the formula sheets. And that unlimited time, you can take that anytime that you want on Thursday, and you can also take it all day on Tuesday, the 28th. So basically, if you take the written test between 10 and 11:15, I'll give you an extra 5%. If you take the final between 9 and 11 a.m. on April 28th, I'll give you that 5%. You know what? I don't have another class. That's fine. I'll do it anyway. I'll just give you 5% if you take it between 9 and 11 a.m. The written part, the computer part, you can take anytime that day. So.
And the final project's due on the 21st, right?
The final project is due the 21st, a week from today. Yeah. So if I don't have it on there, I will post it on there. That you have a just post your PowerPoint on there, and then I will just have you guys narrate. Just here in Teams and tell us about your project.
And only one person from the group has to post it, right?
Correct. And you should be able to know if somebody posted it from your group. So if it's still blank, post it. But the idea here is, you guys have group work. Some groups are more dysfunctional than others. Hopefully you guys are working together. Everybody's checking everybody's answer. There shouldn't be any mistakes because you've got groups of 4 to 6 people. I think all of them have 4 and one of them has 6 that are looking at this, don't say, oh, Caitlin's got the phone calls and Jessica's got the social media. You should all be involved in collecting the data. You should all be involved in checking the work. Usually I get somebody says, well, I didn't do the social media poll, so I shouldn't get marked down. No, you get marked down because you didn't check that they did the work wrong. So it's a group project. That means everybody should be in all aspects of the group project and looking for each other's mistakes and helping each other. So everybody gets the same grade except for you guys are going to rate each other because I have no idea who was helping and who was not helping. But yeah, so the final project should be considered a practice final, a practical final also. You're going to see if you know how to do your confidence intervals and your hypothesis tests correctly. So, all right, so let me jump into, I think I posted our spreadsheet, didn't I? Hopefully I did. Can't remember if I posted that under lecture notes or worksheets from class.
Is the computer exam, is that through Proctorio too?
No, because you're going to have unlimited time.
And one more question about the project.
Okay.
You said that if we'd collected some of the data before the virus hit, that we would get extra credit for it, right?
I think I did say that, but most of you said you didn't collect any data, so I don't know that that mattered. At least that when I asked, nobody collected any data. So has that changed?
I had emailed you that I had.
But you'd only had like 5 things or something. You hadn't done, it was really small, wasn't it?
Yeah, I think it was out of 30 and I had like 15 or 14. So I'm not sure if that counts or not.
15 of what?
Of the asking freshmen and sophomores.
Oh, it was part of the stratified.
Yeah.
You can put it in your final results, because remember, you're supposed to combine all, so you're supposed to do the phone poll separately, you're supposed to do the
Yeah.
social media separately, and then you can combine them. And if you want to, I don't know, if you want to combine that in there, I can give you a little bit of extra credit, but not much. When I asked that before, nobody said they'd done anything, and then I got an email about a week ago saying, oh, we did a cluster, and I was like, how come you didn't tell me that before? Because I asked, and anyway. But I don't think it's going to be very much extra credit, but a little bit if you want, yeah.
Okay.
Did I not post the lecture notes? I thought I did. Here, let me post those up here really quick. And I think I thought I posted our spreadsheet too. This might be the pits here. My problem is I don't even remember where I put it. I gotta find that darn spreadsheet, or maybe I can recreate it really quickly, but I don't really want to.
Can we go over the homework today?
So we'll do that at the end of class today. I wanted to make sure we covered chapter 6, which is mainly Simpsons Paradox. That's the main thing. And then we'll go over the homework because I thought that would be a good review, and we could do that. Oh my goodness, I can't find the darn thing. Okay, well, I'm gonna have to recreate this really fast. I don't know what happened to that file. Let me hit save. Where's my save button? I'm blind as a bat today. Why can I not see the save button? Oh, it's right there. It was covered up, that's why. Okay.
Hey, Rick,
Go ahead.
just one little question, but for the phone numbers, do you want like the phone numbers that we used to call, or does that not matter?
I don't need that. That's actually a privacy violation.
Ah, perfect. Okay, thank you.
The IRB would not like me to know who you called. All right, so I'm going to do this really quick. Okay, so we've got here my total columns here. Okay, now we did our hypothesis test earlier, and we said that there is no significant difference. I shouldn't say that there is not evidence of a significant difference in admission between men and women. Okay?
And this is chapter 6, yeah?
Right.
Okay.
And so the idea was, remember that we had a school. I need to remember my numbers here. Okay. Here, I'm going to copy this because it's going to make it easier. Okay, so what happened was they said, okay, well, remember this is a small school. We only have 2 departments. We did notice that at first, when we did the admit rate, that it appeared that there was a difference. Remember, we had 35 men who were admitted out of 80. There was an admission rate of 43.5% or 43.75% for the men. For the women, it was just 33%. We noticed that the men were about 10% higher. So it appeared that men were admitted at a higher rate, although the test said that there wasn't a significant difference. Okay, so it kind of looks like we've got some conflicting things going on. Okay. So what happened was, you know, they got to the administrators. They said, we don't believe your conclusion. We think, you know, statistics is, you're just making stuff up anyway. And so we don't believe, we think that that women are still being discriminated against, that men are being treated better. Okay. So they said, okay, fine. Well, since this, and oh, by the way, let me just mention this. This is actually a true story that happened at the University of California at Berkeley. The women sued and said, we're being discriminated against. So they said, in Cal Berkeley's case, they actually had 6 colleges that they went. So in our mythical college here, they said, okay, well, let's see here. Let's go look at the numbers. Let's look at the engineering department. In this case, 30 men were admitted out of 30 were denied. So your admit rate is simply 30 divided by 30, or 60, which works out to be a 50% admit rate. Well, the women, 10 and 10, so the women also were admitted at a 50% rate. So it appears that the engineering department is not discriminating against women. Okay, well, that's interesting. So they went to the English department. They said, well, tell us your numbers. And so they did the same thing at the English department. And they said, okay, well, let's figure out your admit rate. Well, 5 men were admitted, 15 denied out of 20. So it totals that 25% of the men were admitted. 10 women were admitted out of 40, also 25%. Okay. So they were able to go back to the department. And here's the funny thing. So this is an example of Simpsons Paradox. Okay. When you combine the entire school together, it looks like the men had a better deal. And the idea with Simpsons Paradox is that if you have unequally sized groups, the associations can actually reverse. Okay. Now, and that's what they actually found that happened. Now, in my case, it's a mythical college. The associations didn't reverse, but we tried to say, look, the men and the women were treated equally. They had the same admission rate in the engineering department. They had the same admission rate in the English department. In the case of Cal Berkeley, one of the interesting things is that the women actually had a higher admission rate in some of the male-dominated fields, such as engineering. And maybe I'll do that here too, 4 and 16. And so in the English department, men also have a lower admission rate. And so this is an example of what you call Simpsons Paradox. The problem is the English department is so much smaller than the math department, than the engineering department, that the engineering department kind of dominates the numbers. And so when you combine them together, like we have here, Okay. Then it looks like the men have it better. But when you look at the individual departments, and this was the case at Cal Berkeley, the men actually were being discriminated against, not the women. So the associations can actually reverse if your groups are unequally sized. And you can see that the engineering department had a lot more admission or people apply than the English department. And so that's an example of what we would call Simpsons Paradox. And so that's the main thing that I wanted you to get out of chapter 6 is Simpsons Paradox. There are a few other things in there. These tables here are called two-way tables. You've got admission, deny, you've got male, female. And so these are called two-way tables. It also talks about marginal distributions. And so the idea here is you can find the percent of, in fact, let me copy this for a minute.
Wait, what's a two-way?
A two-way table is where you're looking at data in two ways. So in this way, we've got men and women. That's one way to look at admissions. And then we've got 4 different categories: associates, bachelor's, master's, and professional degrees or doctorate degrees. So we're looking at it by degree, and by gender. So we're looking at it in 2 ways. So this is what we would call a two-way table. Does that make sense?
Yeah.
Okay. And so they have a thing called a marginal distribution. And I will post this up here. But the idea is one of the it's the distribution among all the variables in the table. So for example, if I said you can find the percent of men and women in the right side of the table. And so we could find what are the percent of women. So these are graduates here. And so in order to find the percents, of course, you'd have to add up the percents here. And then you could also do, so you can think of these totals here as being in the margins. That's why they call these marginal distributions, okay? And so you could figure out the percent of women with an associate's, percent bachelor's, percent master's, and percent doctorate degrees. So you could go ahead, you could figure out these percentages, and a lot of times you put these in the margins. That's why they call them marginal distributions. Okay, 29% have associate's degrees, 45% have bachelor's, 21% have master's degrees, and 4% have doctorates. And then you could do the same thing with the men, and you could figure out the distribution among the men. You could also figure out the percent of women and the percent of men in each of these. So the percent of women with associate's degrees would be 62% of women have associate's degrees compared to the 7% of men. And so these, since we figured these out, sometimes they figure these out in the margins, and so they refer to these as marginal distributions. So you can say of the bachelor's degrees, something seems wrong there. Oh, it's because I did my formula wrong. I was trying to hurry and I didn't do it right. So of the bachelor's degrees, let's do this right. 57% are women and 2% are men. That's the formula I should copy over. So chapter 6 will ask you to figure out what are the percent of women with associate's degrees, and what are the percent of women with master's degrees, or what percent of women have associate's degrees or bachelor's degrees. And so you can figure out these percentages based on either the row totals or the column totals. And so that's what a marginal distribution is. What else is chapter 7? Oh, conditional distribution, distributions among only one. Okay, so these numbers here, so these are conditional distributions. So find the percent of women within each type of degree. Oh, actually, that's over here. So these are the numbers that I've figured out. These are your conditional distributions. Find the percent of women with each type of degree. So 29% of women have an associate's degree, 45% with a bachelor's, 21% with a master's, and 4% with a doctorate. Okay, I'm trying to remember if there's anything else in there. The only other thing that you can do in here, I don't really like stacked bar graphs, but you could say, oh, well, let's figure out, you can insert a column graph, and then it's this one here, okay? So this is what we call a stacked bar graph. I probably would not see very many of these on your final project, but what's interesting thing is this will convert everything into 100%. And so you can see the red, the men have a smaller percentage of associate's degrees than the women. That's funny that they put men and women. Men should be blue and women should be pink, right? Wouldn't you think? Anyway, guess we'll have to flip the rows. But the women definitely have a majority of each of the degrees according to this data. And so this is what we would call a stacked bar graph.
So with the percent like associates or bachelors versus percent of women, how would you know which one to choose, if that makes sense?
That didn't make sense. Say that again.
So if they ask what percent of women have an associates, how would you know to not go to the 29% or whether to go to the 62%?
So find the percent of women with each type of degree. So we're only looking at the women. If you wanted to look at it, if you wanted to look at this one, what percent of associate degrees are earned by women? And so you're just looking at associate's degrees. Whereas in this one, you're looking at each type. So you're looking at the row. So column versus the row.
So if it was the row, you would say what percent of women have associate's degrees?
Yeah, so yeah, I've got it right here. So what percent of women have each type of a degree? 29% of women have the associate's degree, 45% with the bachelor's. Okay. Whereas this one's only looking at, of these associate's degrees, what percent of associate's degrees are earned by women? So now we're looking at the column.
Okay, that makes sense.
Okay. Any other questions? All right, so that's chapter 6. I told you that was nice and short. So the rest of the time, we've got about 40 minutes left. This can be a review of anything you want to ask. Stop the recording for that. But if you want to ask about anything, we can review that.
So what's the
In fact, this one
definition
might be
for,
funded. Go ahead.
for marginal distribution versus conditional distribution?
Well, conditional so they're basically the same thing. A marginal distribution is you're going to figure these percentages out in the margins. So you'll put those in the margins. And the conditional says, well, I just want to look at any one row or any one column. So they're really similar. I think, let me look back at my thing here. So the marginal distribution, here's the definition I gave in my notes. One of the categories in a two-way table is the distribution of values among all the variables. Another way you could figure this out is you could also take and copy this table. And you could say, instead of looking at any row, you could say, okay, well, what percent of women with associate's degrees out of the entire school? So now, let me change this. I'm going to F4 that, make that a common thing. Now this should add up to 100% because I'm dividing it. Yeah, it does. It adds up to 100%. So one way would be rather to convert this to raw, instead of raw numbers, you can convert them all to percents here. Adds up to the 100%. So you can see in this case, this is probably a better definition of your marginal distribution. So in this school, 58% of the women are, or 58% of the graduates are women, 41% are men, 27% of graduates earn associate's degrees, 47 with bachelor's. So this is what you would call your marginal distribution. Whereas these are more of your conditional distributions. Does that make sense?
It's better.
You cut off.
It makes a little more sense.
Okay. I will say with chapter 6, I'm more focused on Simpsons Paradox than I am on some of this marginal and conditional distribution stuff. So if you want to focus more on Simpsons Paradox, that's really where I'd like you to focus your energies on.
Can you do another example of it?
Of Simpsons Paradox?
Yeah, like something that would be related to Simpsons Paradox on that test.
Honestly, I'd have to pull up a problem. Let me see if I can, oh, except for that's not the right book. Let me grab my other book here just one second. For my college algebra, I grabbed my statistics book, and now my statistics book, I grabbed the college algebra book. All right. So these Simpsons Paradox are hard to find because they're just hard to find. Oh, this is a good one. This is one you'll notice. This is always often in the news, okay? Oh, except for I don't like this. Okay, this one deals with the death penalty. Okay, so we've got victim's race. Are they white or black? And defendant's race. Are they white or black? Okay, so they're making me do this. So if I've got 30 here, white victim and black defendant. Oh, I need a better one. I was hoping they would just give me this. Here, tell you what, I'm going to pick a different one. Okay, so do helicopters save lives? So these are helicopters and road, and the victim died or survived. So we've got 64, 136, 260, and 840. Okay, so one of the things that we can do is we can kind of figure out the marginal distributions here. Let's figure out my totals here. Okay. So one way we could do is we could say the percent who died for the helicopter. Okay. So if we look at this, it looks like this divided by that works out to be 32%, and the road is just 23%. Okay. So as we look at this, one thing to consider is if I look at the death rate here, is it safer to be transported by hospital or by road to by helicopter? Or yeah, is it safer to be on the helicopter or on the road, according to this data?
It's safer on the road.
Right. Do you
Which-
believe that?
I don't believe that.
Okay. What might be a possible lurking variable in this case?
Maybe it's like a hospital helicopter where people are like already almost dead. I don't know.
Well, it is the hospital helicopter. One of the things that they found in Vietnam, and the reason why we have helicopters now, is because in Vietnam, when a soldier was badly injured, they used a helicopter to evacuate the person, and so many more people survived than in previous wars. And so they found that it was just amazing. If you can get help, if you can get a person help quicker, you will save their life. Okay. So the problem is so this is an example of Simpsons Paradox. Because if you look at this raw data, your marginal distribution says, well, clearly helicopters are more risky because more people die on helicopters than by ambulance. Okay. So the paradox is, well, we didn't talk about whether they were serious accidents or if they were not serious. Okay. So one of the things that we can do is we can take this same, here, I'm going to copy this here and here. Okay, whoops. But this time, we're going to categorize them as serious versus not serious, because the helicopters only get the serious patients. And so if we go 48 and 52 and 60 and 40 and 16 and 84 and 200 and 800, you can tell with these nice round numbers they've made it, these numbers. Okay, so if we take the percent who died with serious accidents, sorry, I need a total in there. Total. Okay, I'm going to copy my formula here. And if we look at serious accidents, you can see that helicopters are now the safer way to go than the ambulance. Okay. And if we take the not serious accidents, once again, you can see that the helicopters are the safer way to go than the road accidents. So as we look at these two tables, helicopters are better. As we look at the combined table, helicopters are worse. And the main reason is if you look at total number of accidents, you can see there are 1,100 not serious accidents versus 200 serious accidents. And so these numbers overwhelm, and you can see that by road, there's so many more people are taken by ambulance on the road than the helicopter. They don't use helicopters for not serious accidents. I mean, they do, you know, occasionally, but these numbers overwhelm the numbers, and so therefore, when you combine the data, it looks like road is the safer way to go than the helicopter, when in fact just the opposite is true. The helicopter is safer in both situations. So this is a perfect example of where the associations actually reverse when you do this. Does that make sense? Are you guys still hearing me? Everybody's muted.
I don't really get it, but I'll just go, if you just post it, I'll watch it over and over again until I understand it.
Okay, so you're confused about this example here?
Could you like list out steps for what we're supposed to do? Because I'm not really sure what's actually happening. And it's probably just me. Maybe everyone else is paying attention, but I just don't really know what's going on.
Yeah, I don't either.
That's my bad.
I mean, these are just simple calculations. I don't know that there's any steps. So if you've got tables here, if I ask you the percent who died by helicopter, you can just figure out the marginal distribution. You get the total. You say percent who died. Well, that's 32%. The percent who died on the road, that's 23%. So as we look at this, I mean, these are just very simple percents. So 32% died by helicopter, 23.5% died by road. So it looks like here helicopters are less safe. You understand how I got those numbers, Caitlin?
Yeah, I think I'm just overcomplicating it. So really you just want us to find percentages?
Yeah.
Oh,
Yeah,
well,
that's all chapters.
Write a definition for Simpsons Paradox. Why is it important?
Okay. An association that holds for all of several groups can reverse direction when the data are combined to form a single group. Okay. So here's what I'm saying. It looks like, as we look at this first table, helicopters are less safe. More people die in a helicopter on their way to the hospital than if they go by road. Okay. Now, there's a lurking variable. The lurking variable is, are they serious accidents? Okay. If we look at serious accidents, life-threatening injuries here, okay, we're going to do the exact same calculation we did here, but now we're going to break it up into serious accidents and not serious accidents, okay? So if we look at serious accidents, helicopters perform better. 48% of people died versus 60% of people died. Okay, so if I'm in a serious accident, do I want to go in an ambulance or do I want to take a helicopter?
The helicopter.
I'm going to take the helicopter, okay? This is just the opposite, okay? When I look at these percentages, this is 48 versus 60, that's the opposite of what's shown in the first table.
So it's
Okay.
just, why don't they just use the second graph then? That's because it seems to be the more specific one. Are they just trying to prove that, like, you don't believe everything you read?
Well, yeah, to some degree that's the case, okay? So the idea here, Simpsons Paradox says, okay, so we've got a lurking variable, and that's how serious the accident was, okay? In both cases, the helicopter is safer. It's safer for serious accidents. It's safer for less serious accidents, okay? The problem is these groups, 200, so I've got 200 who had serious accidents. I've got 1,100 who had not serious accidents. These groups are unequally sized, 200 versus 1,100. This is 5.5 times larger than this group, okay? And because this group is so large, especially this category here, we're putting 1,000 people here. And so these numbers, it looks like, helicopters are a safer way to not die. But if we combine these two tables together, 48 plus 16 equals 64, okay? If we combine them together, it looks like helicopters are less safe, when in fact, they are actually more safe. So all I'm trying to do is illustrate Simpsons Paradox. The comparison reverses when you combine the data to form a single group. This data should be kept separately, as we did here.
But that's only in specific circumstances. Like, it could be possible that still more people die in a helicopter because 0.48 and 0.6 are pretty close together. So, like, Simpsons Paradox is only for specific situations, right?
It's only for specific situations. But once again, so this is the same thing. So remember last time we talked about people believed that there was discrimination among women. So they went to this college and they said, look, the admission rate for men is 43%, it's just 33% for women. So clearly there's discrimination going on. Women are being discriminated against. There's a 10-point difference in discrimination. Well, we did our hypothesis test and we said, no, there's not a difference. So, because you would say, because doesn't 10% sound like it's a big difference?
Yeah.
Yeah, but it's kind of a small sample size, only 140 students. But when we went to the school, okay, the first time I did this, I made it perfectly even. It was 30-30, right? And I did 5 and 15. So we said, look, there is no difference in admission rate among the men or the women. There's no difference at all. And so the problem was, because we combined the engineering department and the English department, it looked like, it appeared that men were admitted at a higher rate. It appeared when you combine all of the data together that there was discrimination. But when you break it down by department, there is no discrimination. So this is an example of Simpsons Paradox, where if you have unequally sized groups, the associations can reverse. Okay? And in fact, this one they didn't reverse. It just said, look, the admission rate, men and women are being treated equally. In this case here, with the helicopters, it looked like helicopters, when you combine the data, helicopters, it's worse to be in a helicopter than not. But the reality is they only send helicopters for serious accidents. They don't send them for non-serious accidents. And so these numbers, because there are more not serious accidents, these overwhelm the serious accidents, and it looks like helicopters are worse when in fact helicopters are better.
I understand it now. Thank you.
Okay, all right. Okay, so we've got about 15 minutes left. What would you guys like to go over for the review on the test?
Can you just do like
Chi-square.
practice problems? Yeah.
Okay, so here's what I wanted to do. Since we haven't, this is just some raw data. Maybe I'll copy these. Okay, we were talking about these in the context of a marginal distribution. But let's leave this here and let's ask the question, is there a significant difference in degrees by gender? Would be our hypothesis test. Okay. And so let's go through this. This is what someone will say to you as a non-statistician. Okay. So
the homework doesn't ask questions like that though. So it was hard to know like kind of what we were looking for. It was just super confusing. So they wouldn't give us the alpha, so then it was hard to find the chi-square. And
so if they don't give you the alpha, what do you assume?
0.05.
Right.
And I did, but then I got those wrong.
Yeah, I'm with Tori. That homework was crazy.
Yeah, I did not get it.
And the degrees of freedom equation didn't work either.
But
Okay.
like, I understand what you taught us, but I feel like the homework just wasn't what you taught us. But I understand, like, if you just test us on what you taught us, I think we'd be fine.
Yeah.
Okay. Well, let's do that then. I'm happy to go over the homework.
Can you go over a question on the homework?
Go over what?
Question 8 on the homework.
Okay. So I'm not going to record the homework. So I will stop the recording here. But yeah, we can do that. So.